Hello, we are Team AI Alert and this presentation is about our final year project, Unmasking Hate, an integrated approach to detecting hate speech in social media. Hate speech is a persistent and multifaceted issue in human communication, presenting in numerous forms with distinct characteristics. It is challenging to categorize hate speech and other related definitions, as direct categorizations in research are scarce. This slide shows one such categorization. As we can see, hate speech can be of different forms. For example, racism, cyberbullying, radicalization, etc. Motivation. Our motivation stems from recognizing that online hate speech extends beyond individual harm, creating a climate of fear and intimidation that impacts entire communities and undermines democratic foundations. Historically, hate speech has been linked to real-world violence, including civil wars and genocides. Social media amplifies hate speech through anonymity, echo chambers, virality, limited moderation, and global reach, exacerbating its harmful effects. Therefore, the spread of hate speech is increasing in today's world compared to the previous times. For example, recent conflicts between Israel and Hamas have led to a surge in anti-Semitic and Islamophobic hate speech online. Instances of anti-Semitic content on X have soared by over 919% since October 7, while anti-Muslim hate speech has also seen significant increases. This rise in hate speech has been linked to real-world violence against Jews and Muslims, highlighting the urgent need to address this issue. Problem statement. The current state-of-the-art model for hate speech detection that uses contrastive learning is Dual Contrastive Learning Framework, which will be called as DCL framework from here onwards. It relies on fine-tuning a pre-trained BERT model to capture contextual semantic information. However, this approach may not effectively detect hate speech due to its evolving nature and embedded emotions. We propose an integrated approach combining DCL with emotional analysis, author profiling, and a time-aware language model to enhance detection accuracy. Research objectives. Our research objectives include improving hate speech detection performance of the baseline DCL framework using fine-tuned embeddings, incorporating emotional context recognition, implementing author profiling for better context understanding, and developing a scalable technology platform for widespread use in combating online hate speech. Methodology. These are the datasets we have been using in our project. Those are mainly extracted from Twitter. This is the baseline model DCL framework. Here, the BERT encoder model is used to get the embedding of each input tweet of the input batch. These embeddings are then passed through a data augmentation method where the new embedding is generated for each embedding in the input batch using a dropout layer. When we generate an embedding using an original embedding, that pair is known as a positive pair. Every other combination in the same input batch is considered a negative pair. Then, both self-supervised contrastive learning and supervised contrastive learning losses are calculated using the obtained positive and negative pairs. These embeddings also go through a classifier to output a prediction from which the focal loss is calculated. The final loss is the sum of all of those three losses. We also fine-tune the pre-trained language models to better suit our downstream task, which is detecting hate speech. We have considered several pre-trained language models, namely BERT, Roberta, BERTWheat, and TimeLMS. In our emotion modeling phase, we focused on 11 distinct emotions, categorized into negative and positive groups. Here is an example output vector from our model. This is the model that we used for emotion modeling. It is based on research by Francisca et al., and it is a Roberta-based model. It was trained on 154 million tweets up until December 2022 and also further fine-tuned. Author profiling approach is divided into two main parts, style linguistic-based features and personality-based features. For personality-based features, we utilize the Big Five personality traits: extroversion, agreeableness, openness, conscientiousness, and neuroticism. This is how we integrated the vectors. We combined sentence embeddings from our fine-tuned pre-trained model with emotion and author profiling feature vectors. These are appended together to create a comprehensive representation. Here it's illustrate our overall high-level architecture, divided into two main sections. First, we fine-tune the encoder model, which is used to get the embedding as the first step of our framework. As explained earlier, the loss used is the sum of the self-supervised contrastive learning loss, supervised contrastive learning loss, and focal loss. Next, we use that fine-tuned encoder model to generate sentence embeddings. We also include emotion vectors and author profiling features. These vectors are combined and passed through a dropout layer for regularization, followed by a feed-forward neural network that learns classification patterns. Finally, we apply a softmax function for classification and use focal loss for optimization. Results. We conducted a series of experiments to evaluate the performance of the DCL framework when integrated with fine-tuned models, emotional profiling, and author profiling. Our primary goal was to enhance the accuracy and macro F1 scores in hate speech detection. Our first set of experiments focused on the integration of DCL with various fine-tuned models, including BERT Base-Cased, RobertaBase, TimeLMS, and BERT Tweet. We observed notable improvements in both accuracy and macro F1 scores across all models, compared to the baseline. The highest improvements were seen with the TimeLMS and BERT Tweet models, achieving accuracy of 79.92% and 80.1% respectively. Next, we integrated emotional profiling into our models. This addition further improved the results, with TimeLMS plus emotion achieving an accuracy of 81.2% and a macro F1 score of 81.09%. This demonstrates the importance of considering emotional context in hate speech detection. Author profiling was the next enhancement. The integration with author profiling showed positive results, especially with TimeLMS plus author and BERT Tweet plus author, achieving accuracies of 81.39% and 80.98% respectively. Although there was a slight decrease with the BERT Base-Cased model, the overall trend highlights the value of author characteristics in improving detection accuracy. Finally, we combined all elements, DCL, emotional profiling, and author profiling. The results were compelling. TimeLMS plus emotion plus author achieved the highest accuracy of 81.31% and a macro F1 score of 81.22%, solidifying the importance of a holistic approach in detecting hate speech. When comparing our best model, DCL, emotion, and author, against the baseline DCL model, we observed substantial improvements. For the relabeled hate val dataset, the accuracy improved from 77.94% to 81.28%, and the macro F1 score increased from 77.74% to 81.21%. Similarly, for the unified dataset, the accuracy rose from 74.59% to 76.48%, and the macro F1 score also saw a significant increase. Let's move on to the analysis of our findings. We conducted a feature importance analysis on the TimeLMS DCL model with emotion-based features. Previous research has highlighted negative emotions such as anger, disgust, fear, and sadness as crucial indicators of hate speech. Our key findings align with this, indicating that emotions like anger, joy, fear, anticipation, and sadness significantly contribute to hate speech detection. This underscores the necessity of including a wide range of emotional contexts, beyond traditional negative emotions, for a more comprehensive understanding. Model deployment. We deployed our model in Huggingface spaces. Let's have a demo. Here is our deployed model. Let's try some examples. You can see it gives non-hate as the output for the input and hate speech percentage as 0.25% and non-hate speech percentage as 0.75%. Furthermore, it's showing emotion analysis as well as personality analysis for the text. So for this example, it has majority personality type of extroversion. Let's try another example as I hate you. It gives the output as hate, but its hate speech percentage is somewhat low. Reason because that is this example is not pointing to a person. So it cannot be directly say it's hate or not. So let's try some other examples. For hate, and non-hate. Finally, in conclusion, our study introduced a novel approach using dual contrastive learning with transfer learning, emotion modeling, and author profiling for improved hate speech detection. Experiments on the hate val and unified datasets showed that fine-tuning BERT-WheAT, time LMs, and Roberta models led to superior performance, surpassing baselines. Incorporating emotion analysis and author profiling further boosted classification accuracy, emphasizing the importance of considering emotions and context in hate speech detection. Thank you very much.